All right, guys, test 28, getting close to the end. Let's work out this practice test. So be ready for tomorrow. All right, first one is kind of a review from last week. 4 to the x is 25. Remember, if you can't find the same base, you do log both sides. The exponent goes in the front. So I'm going to put that exponent in the front. Then to solve this thing, I'm going to do log 25 divided by log 4. Just going to punch that straight in the calculator. All right, I punch it in. I'm getting 2.3219. Make it a little bigger. Okay, number two. Number two has a log in it already. So I'm going to take, remember the way you work a log is you take that base to that power equals x. So I'm going to say x equals 5 to the third power. Everybody knows 5 to the third power is 125. That's all you got to do on that one. Number three is just like that, except it's an ln. Anytime you see a natural log, remember it's base e. So I'm going to do e to that power equals x. So I'm going to say x equals e to the negative 5 power. I'm going to punch it in real quick. When I punch it in, I'm getting 0.006. Oops. Can't write it. I said it. 0.0067. And that should be number three. Number four has two logs that are subtraction. Remember, when you see subtraction of logs, you actually do division. So I'm going to say a log of x over x plus 3 equals negative 1. And because there's no base written there, remember that means it's base 10. It's a common log, base 10. You raise the base to that power, and it equals that. So I'm going to say x over x plus 3 equals 10 to the negative 1. Now, 10 to the negative 1, I'm going to erase this right here. It's really 1/10 because the negative exponent means you flip it. It's 1/10. And because I have one fraction on each side, I'm going to cross multiply here. 10 times x and 1 times x plus 3. Move that x over. 9x is 3. Divide by the 9. You get 3/9, which is really 1/3. Number 5. Number 5, very similar, yet a tad bit different. All right, this one also has subtraction. So subtraction means division. So I'm going to make this one log on the left-hand side, and it equals log base 3/6. Now, this is a different kind of problem because there's a log on each side. Whenever you have one log, I hope you hear me here, one log on each side, not two like we had a second ago, you can cancel out the logs because they're already equal. So I'm going to say x plus 8 over x plus 1 equals just 6. Again, that's really 6 over 1, so we're going to cross multiply here. 6x plus 6. The 1 times the x, I don't know why I put an x there. Sorry about that. The 1 times the x plus 8, which is x plus 8. Move that x over. Move the 6 over with the 8. And you get 2/5. Now, you do need to check and make sure it keeps your logs positive, which it does. So we're good there. Number 6. Another subtraction, lots of subtractions in this thing. So remember, when you subtract, if you don't know by now, that means you divide. So we're going natural log of x over x minus 4 is natural log 3. Because there's one log on each side, you can cancel those logs out and get x over x minus 4 is equals 3, which is root 3 over 1. Cross multiply like we just did, and you get that. Let's take the 3x over here this time, which would give me, I keep putting x's in everywhere. What is wrong with me today? So take the x over, you get negative 2x. Divide by negative 2, you get 6. Check it to make sure it keeps the logs positive. It does. We're in good shape there. So there's 6. That's all I got on my first slide. And number 7 and 8. 7 and 8, still log equations here. Lots of log equations. Okay, this side, both sides have addition. Remember, when you see addition, that means you multiply. So we're going to say x times x plus 1, which is x squared plus x. Over here, multiply 2 times x plus 3, and you get 2x plus 6. Again, we got one log on each side. You can drop those out, and you get here. Because I have an x squared, I'm probably going to have to factor, so I'm moving everything over. X squared, oops, sorry about that, minus x minus 6 is 0. Factor that thing, x minus 3x plus 2 is 0. So I get two answers, 3 and negative 2, except if I plug negative 2 in that very first log or in this one, they both become negative, so that don't work. Will not work. The 3 looks pretty good, so I'm going to keep the 3. Number 8, one more. It has one log. Whenever you have one log, you actually do the log. And the way you work out a log is you do 2 to that power equals that. So I'm going to say 8 minus 7x equals 2 cubed. All right, 2 cubed, in case you were curious, is 8. So if I move the 8 on this side over there, there's obviously going to cancel. Divide by negative 7, I get 0. Now make sure 0 is okay. If I plug it in there, yep, still good. Everything's good. I like it. There's number 8. Let's go to number 9. All right, number 9 says population growth. It says in 2011, the population of Mexico is about 113.7 million, and the exponential growth rate was 1.1% per year. Find the growth function. Okay, so for population growth, we're using this function right here. We're going P of T, population, equals P sub 0 e to the kt, where k is the rate, t is the time, P sub 0 is the initial population. So just to write, this is part A, by the way. So just write the function, just plug stuff in. So I'm going to say, okay, the initial population was 113.7, remember that's million, equals the rate is 1.1%. So I'm going to change that to 0.011 and then t. Okay, so that's the answer to part A. That's the function right there. And then part B, just going to want you to use that function. So what was population in 2016? Well, we started in 2011, so 2016 is 5 years later. So I'm going to put 5 in for that time. So what I'm punching in my calculator is I'm punching in 113.7 times e to the 0.11 times 5 power, because that's going to give me what the population was 5 years from now. When I punch that in, I'm getting 120.1 million. So gone up quite a bit in 5 years. Number 10, suppose that $3,000 invested at interest rate K compounded continuously and grows to $3,600 in 5 years. Part A, what is the interest rate? Okay, we got to work backwards here a little bit. I know it ended up at $3,600, so I'm going with $3,600. It started at $3,000. I guess I should have written this. The formula for this is it's PERT, so it is like, I guess I should put P of T. Again, the initial amount, e to the RT power. Okay, where R is the interest rate. So 3,000 is the initial amount. E, I don't know the interest rate, that's what I'm looking for, but it said it grew for 5 years. So the first thing I'm going to do is I'm going to divide both sides by 3,000. So I'm doing 3,600 divided by 3,000. See if I punched it in wrong. Give me 1 second. This is live video. It gives me 1.2 equals this, e to the 5r. Anytime you want the e to go away, remember, you're doing natural log of both sides. So I'm doing natural log of 1.2 equals 5r natural log e. And natural log just takes care of the e. So to get my final answer, I'm going to do natural log of 1.2 divided by 5. And that's going to give me my rate. So punching in right now, natural log 1.2, close your parentheses, divided by 5. And I'm getting this, 0.036. So my interest rate is like 3.6%. So find the function. To write the function, I'm just going to say, okay, the amount is going to be the initial amount, which is 3,000, e to the 0.036 t power. How much will it be after 8 years? So after 8 years, I'm just going to plug in the 8. So I'm going to do P of 8 is 3,000 times e to the 0.036 times 8. Just going to punch that straight in again. I'm doing a lot of punching on this problem. 3,000 e to the 0.036 times 8. And I'm getting this much money, $4,001.27. And then part D, after how long will it should say 3,000. How long will it take to double it? So if you double 3,000, I'm losing answers, by the way. That's the answer to C. Let me change colors for D. To double 3,000 means you would end up with 6,000. That's going to be 3,000 E, and I know all this is true. It's asking me how long. It's asking me for the time. So I'm going to solve this just like I solved the one over here. Divide by 3,000, that's 2. I can do natural log both sides, which basically gives me natural log 2. And over here it takes care of the E, so I get 0.036t. Got to move it up just a little bit. So to get my final answer, I'm going to divide natural log 2 divided by 0.036. And I'm going to punch it in right now. Natural log 2 divided by 0.036. And I'm getting 19.3 years. It's going to take 19.3 years for that to double to $6,000. Number 11, solve with the graphing calculator. Now, all you got to do, I'll talk you through the steps here, but the first thing you do need to do is get the y by itself. So I'm going to first, I'm moving the 1 over. There's my first equation. The second one, I'm moving the 1 over. Now, one thing I'm noticing already is my slope's the same. So they're actually going to be parallel, which means no solution. But let's talk through the steps of punching them in. Going to y equals first, punching in 2x minus 1 where it says y1, punching in 2x plus 1 where it says y2. Then I'm going to go to zoom 6. Zoom 6. It's graphing both of them right now. What I'm looking for is where they intersect, and they don't intersect. But if they did, I would go to second calc, intersection, second calc 5. 5 is intersection, and hit enter 3 times, and it will tell you exactly what the intersection point is. But because these slopes are the same, There was no solution. Don't expect that to happen tomorrow. I just don't think it will. Okay, number 12 says substitution. You must show your work. Because I know what x is already, x is this. I'm going to plug it in for the x right there. So I'm going to take where the x was, I'm going to put negative 3y plus 3. Keep the 4y equals 6. All right, if I add that stuff up, I'm getting 1y plus 3 is 6. Move the 3 over, that gives me 3. So that's my y. That's not the final answer. You got to find your x. Now, the great thing about substitution is you can plug it back in right where you started. So if I plug it back in right there, I'm going to get negative 3 times 3 plus 3, a bunch of 3's. That's going to be negative 9 plus 3, which is negative 6. So my final answer, negative 6, 3. Answer should be an ordered pair. Number 13, solve by elimination, means I need to make one of my variables disappear. It looks like it's going to be the easiest thing to make that 6x go away. So I'm going to multiply the whole top by negative 6. So I'm going to get negative 6x plus 18y and negative 12. And I'm going to bring this one straight over. I'm just going to add those equations together. The 6x's are gone. That leaves me 23y. Over here is negative 46. And the beautiful thing is 23 just happens to go into 46 two times. So y is negative 2. You got to take that and plug it back in one of these equations. The top one looks much simpler, so I'm going to plug it in for that y right there in the top. That gives me x plus 6 is 2. And if I move that 6 over, I get negative 4. So my final answer there, negative 4 and negative 2. And you can check that just by plugging it in one or both of those equations. Number 14, find all the zeros. First of all, let's make a list. Put the factors of the last number over factors of the first. The factors of 27 are right there. That's all over 1. The factors of 2 are 1 and 2. So I'm putting 1 over 1, all those over 1, then I'm putting all over 2. 3 over 2, 9 over 2, 27 over 2. And I'm going to punch in my calculator and see where the x-intercept is. Okay, it looks like it's crossing it, like negative 1.5, which, by the way, that's that one. So I'm going to put the negative 3/2 in the box. And also, I really like this because what I noticed as soon as I wrote those coefficients, that's the thing about that's 2/3. That's 2/3. So it should work. Bring the 2 down here, multiply. You can use your calc if you need to. Multiply those 2. That's going to give you negative 3, which gives you 0. Anything times 0 is 0. Bring the 18 down. Multiply negative 3/2 times 18. You'll get negative 27, which is 0, which should happen if it actually works. So what I have left is this. 2x squared plus 18 is 0. Let's move that 18 over. Let's divide by 2. Let's take the square root of both sides, which gives me plus or minus 3i. Don't forget the I because it's negative square root. So my final answer, all 3 zeros. I had negative 3/2 and also had plus or minus 3i. And those are your 3 zeros right there. Number 15, last one. Let's factor this thing. So I'm going to factor and going x plus 2, x minus 1 is greater than 0. Now remember when we solve these inequalities like this, we made a little sign graph down here. I put the zeros, negative 2 and positive 1. Then I plugged in 100 every time. If I plug in 100, that becomes 102. That becomes 99. Don't know what that is, but I know it's positive, which means everything over here is positive. Everything between there is negative. Everything there is positive. And I'm looking for, look what it says, greater than 0. So I'm looking for the positive signs. 1 is over here less than negative 2. I'm using a parentheses because there's no equal sign. And there's also a positive past the 1. And there you have it. That's all you got to do for 15. Hope that helps you. Just do good tomorrow. Getting close to the end. Let's finish strong. See you then.